Okay, so let's go over, I'm going to just show you quickly how the code is for drawing the left and right paddle. These are my arguments, so position, thickness, color, all these things are pretty straightforward. Moving the paddle is also pretty straightforward. It's, hey, is the keyboard pressed for W? Go ahead and move it up. I'm moving my paddles at 300 pixels per second. And this is all you need to actually move the paddles. So when I'm running my game, I'm going up and down. So how do you constrain this so it doesn't go halfway up here, right? So it's actually almost identical to how the ball is being constrained. You're essentially going to be bouncing the paddle off the top. The only difference is that you're not really bouncing it. All you're doing is you're forcing it so that it can't go off the edge of the screen. Right now I move up and down and I can move these things off the top and bottom of the screen. But we can use the same idea of the ball bouncing off the screen to constrain the paddles. And I'm going to just start off really simply here just to show how it could work. We're going to set up another if statement here. We have these 4 if statements right here. This is basically our ball bouncing around the 4 walls code. In fact, I'm going to comment it as such. Ball bouncing off the top wall, like that. I'm going to add a comment here for ball bouncing off the bottom wall. This is the ball bouncing off the left wall. And this is the ball bouncing off the right wall here. Just so I know easily like what this is. I'm going to write another if statement though. Let's do the right paddle to start. If the right paddle here, which is the name of my paddle variable, if I get its position.y and it's less than 0, and I'm actually going to change this here. I'm going to move this if statement. I have all this code for moving it. I'm going to make sure that my code that moves the paddle happens before I do all this if statement. So here's my code that I'm going to put comments here. Move paddle, move left paddle up. This is going to be moving the left paddle down. Move right paddle up. And move the right paddle down. And right below this movement code, I'm going to do an if statement. I'm going to see if the right paddle position.y is less than 0. All I'm going to do is I'm going to set the position of the right paddle, just like what we do here. I'm going to it's almost going to be identical here. I can even copy this code from the ball. And instead of the shape, it's going to be right paddle. And this is going to be the position here. And instead of the radius here, we don't have a radius here. I'm just going to use 0 to start just to see what happens when I just plug in 0 here. So I'm going to move the paddle up, and I hit up, and it's popping up there. Did I do this right? Left get position.y less than 0. So I can move down, I can move up and down, and I'm going to hit up, and now it's stuck up there. Right? Because the top edge of the paddle is going off the top edge of the screen. The position of the paddle is actually the top left corner. The top left corner of this paddle is where the position is. If I were to draw a dot, the position of the paddle here is going to be moving. Like this is basically at the bottom edge of the screen. That's the position of the paddle there. So now I can constrain it. Now I'm holding up and it can't move off the edge of the screen. And all I did was say, hey, if the position of y is less than 0, do this, which is reset it. I could do this for the left paddle too. So I just changed this. It's the same code. I'm just going to do this for the left paddle now. Just replace all the place where I said right. So now both of my paddles on left and right will not be able to move above the screen. So they're both stuck. Okay. Getting it off the bottom of the screen is the same idea as the ball too. If I take this logic for the ball bouncing off the bottom wall, I'm just going to take this if statement, and I'm going to copy it from the ball bouncing and move it up here for the paddle. I'm going to change this to be, instead of the shape here, I'm going to use the paddle. If the paddle's position on y, and let's just do this to start, is greater than 512, which means it's off the bottom edge of the screen, set the position equal to, let's just set it equal to 512. Nothing more than that. This is just setting the position equal to 512. I'm not accounting for the height of this paddle at all, but we will. So I'm going to move this paddle off, and there it is off the bottom. Looks like it's a shark. It moved. We don't actually want that. position.y is greater than this. It's greater than 512. Set the position. Oh, because I don't want to setting it to the oops. I didn't replace this with the right paddle. So this is still what it's actually doing is it's teleporting the right paddle to the position of where the ball is when I'm moving it down. So see where it's moving with the ball? So yeah, that's what happens when you don't rename all the variables. So this has to be right paddle dot get position here. So now the paddle is constrained to the bottom. However, you can see the little paddle peeking up near the bottom, but it's not accounting for the height properly. So I know the height is actually 100 here. You can actually get the height, though, from the paddle itself. So just like how the ball down here accounted for the radius, the paddle here, I can account for the size, too. So right paddle has a function called getSize. And getSize has two parts, a width and a height, which are x and y, respectively. So you can call getSize.y here. And in here, we're going to do the same exact logic. We're going to subtract that from 512. Okay. So this logic here is almost identical to the logic here. So I'm just going to copy these two. I'm just going to show you what the difference is between these two. So this one is the paddle. Paddle set position, right paddle get position. Shape set position, shape get position. And they're both subtracting 512 by the size. Okay. All right. So let me run this and test it. So this will constrain the paddle position so that it won't go off the bottom edge of the screen. So that code right there, right here. So I can move the right paddle, and now it's stuck to the bottom edge of the screen. And then I just have to copy this code for the left paddle. So I can copy this whole if statement, put it down here, and replace right paddle here with left paddle. All right. I'm going to comment this one, constrain left paddle to edges of screen. And this one's going to be commented, constrain right paddle. All right. So all we're doing is we're counting for the size of the paddle. So now both of these are fixed to the position of the screen. Cool. All right. Now comes the fun part. So this is basically the extent of what we're going to do with the paddle. This is done. Like this is Pong paddle movement. We don't have to do anything else with it. All this code here for constraining the edges and moving the paddles, this is how the Pong paddle movement is working. So we are like 30% of the way to making Pong. So what I want to do is I'm going to show you guys the lab, but we're going to do this. I'm going to explain how to do collision detection here. We've actually been doing collision detection already. We've been doing collision detection with the ball and with the paddles. I want to go over how you would do collision detection with shapes that are already in the game, as opposed to just the outside edges of the window. So I'm going to set up a simple example here that's going to hopefully highlight how collision detection is going to work. I'm going to make a giant paddle, and I'm going to hide all the rest of this. And I'm just going to move my paddle here. I'm going to make this thing like 200 by 600, maybe 400. And let's set this guy right in the middle of the screen. Okay, he's a little too big. So I want to do collision detection with this being my paddle, right? This guy right here. And the first thing I want to do is I want to detect if something is inside that paddle. And specifically, I want to make it so that when the mouse is over the paddle, it changes the color of the paddle. So I'm going to detect when something is inside this paddle. So collision detection with a rectangle is broken down into actually 4 different solutions, like 4 different things that you have to check for. There are 4 different ways that you have to basically be inside this rectangle, right? If I have my mouse cursor here, and it's on the left edge of this rectangle, before I draw. So that mouse cursor is obviously not inside the rectangle, right? And we know that this is inside the rectangle here. But how do we know that? Like, how do we know that this mouse cursor is actually within the bounds of the rectangle? In fact, there are actually 4 different imaginary kind of quadrants that you're in when you're looking at a rectangle here. I'm actually going to draw this on the whiteboard. So, but imagine that, you know, if you're watching this at home, they're going to be left, right, and top and bottom sides I'm about to draw. I'm going to change the color here to be white just because I need it to be a little bit more visible. Solving for rectangle collision is actually a matter of solving 4 different separate collision equations. Okay? Look, my stuff from last week is still here. There are actually 4 different imaginary quadrants here. I'm going to draw them out here. Hopefully I have 4 different colors. I'm just going to draw lines that go outside of each side of the rectangle, so off the left and right sides, and then off the top and bottom as well. This would be good enough. Okay. These are imaginary quadrants, spaces that are occupying the edges of the rectangle. Right? So, solving collision for a rectangle, whether a point is inside it, is a matter of making sure that the point is within all 4 sides at the same time. So, for instance, I'm going to put my mouse cursor down here, down on the lower left. And the way you approach this is you have to ask 4 questions to see if a point is inside. 1, is the point that I have completely within the left side of the rectangle? Which means, is the point that I have, let's just say over here. I'll move this up here. So if you imagine this rectangle, this point is completely to the right side of this left edge here. So imagine that this purple zone basically is everything that is to the right of the rectangle, right? This mouse cursor is currently within the purple zone. Cool. I know that this is. And in the middle here, and I can't really, unfortunately my rectangle is not the right color, I have a mix of all these different, these are actually all 4 sides that are together, right? The first question I want to answer is my mouse cursor here to the right of this edge, right here? Right? Is it to the right of this edge? Is it on this side? Is it in the purple? And it is. Cool. That's one question answered. Okay, I might have a collision here. All right. The next question I want to ask is this mouse cursor below the top edge here? You can tell that, right? Because the mouse, this is the top edge and it's below that. Cool. So 2 questions answered. We know that it's to the right of this, and it's below this. Is my mouse cursor above the bottom part of this rectangle here?
Yes.
It is, right? Because, again, this is the bottom. The mouse cursor is in between the bottom and the top and over here. And the final question you need to ask is the mouse cursor to the left of this edge right here? It's not. It's not inside. So I answered 3 out of 4 of those questions correctly, but it's not missing, it doesn't have that final piece. So when does that actually become true? As soon as this mouse cursor goes over here, right? Now the mouse cursor is to the right of this edge, below this edge, above this edge, and to the left of this edge. Keep in mind that you have to have all 4 correct. So if I move it down here, this mouse cursor is to the left of, to the right of this edge, below this one, to the left of this one, but is not above this guy right here. Okay? This mouse cursor has to be in all 4 of those sides at the same time. It has to be inside the intersection of all 4 of these rectangles, this guy right here, which happens to be the rectangle itself. So if it answers only 3 out of 4 of those questions correctly, then you don't have a collision at all. Your mouse is not inside that rectangle. So we need to write an if statement that basically is solving for all 4 of those questions. We're going to write an if statement that says, hey, is the mouse cursor to the right of this? And is the mouse cursor to the left of this? So in the lab, and I'll do this for you, you're going to solve all 4. I gave you 2 out of 4 of these inside the lab. I give you a little snippet here, a snippet of code. This code I give you right here will change the color of the paddle if you're between the left and right sides of it. So let me show you what this is. I'm going to put this inside our. I'm going to put this inside of the code that I have, and you guys are going to use this. And then you're going to add to this to make it work for all 4 sides. So I'm going to take this code here. I'm going to put an if statement right below all our constraining code. I'm just going to paste this in because I happen to call it the same. So if my mouse is, so look at this if statement that I've set up here. Let's start off a little simpler. I'm just going to delete everything except for 1. I'm just going to set up one of those 4 questions. I'm going to set up the first question I asked. Is my mouse to the right of this left edge here? Is my mouse over here? Okay? And if it is, I'm going to set the color of my paddle to be white. So I'm going to start over here. Is the mouse to the right of the left edge? And it is. Anywhere around here, it's true. Let me make the background not white also, so we can see. So the first question I'm answering is, hey, is the mouse to the right of that left edge? Okay, so you can see here, I'm getting right to the left edge, and it's turning. Doesn't matter where I am vertically, and it actually doesn't matter if I'm over here. As long as it's to the right of that left edge, this thing turns white, right? So that's what this question is answering. Hey, is the mouse currently to the right of the paddle position? Remember, the paddle position here is the top left corner. That's where the paddle is, right up here. So now what I want to do is the paddle to the left of the right edge? So I'm going to put up another condition here. Is the mouse position .x less than the position of it plus, and in our case, our paddle size here is going to be x. That's going to be the width. So this condition right here will only be true now if I'm between the left and right sides. So I'm going to go over here, and it's white, and then goes back. Okay, so look at the mouse cursor. It's still flickering here down below because we haven't answered the 3rd and 4th question is, we only want it to happen when you're below this top edge and above this bottom edge over here. Okay? So this mouse cursor is now flickering it white as long as I'm in between those 2 edges here. Okay? So what I want you to do for lab is finish it off so that you write the remaining 2 questions, which is the mouse in between the top and the bottom edge of this rectangle? And this is how we're going to handle ball collision, because we're going to use these same questions to answer if the ball is inside our rectangle to bounce it. Okay? All right, so that's lab. Once you're done with this lab here, we're going to take a break, and then we'll come back and we'll finish off the ball collision logic. All right? So once you're finished making the paddle glow white when the mouse is inside of it, you can take a break. Or we'll take a break at like 11 o'clock if we need to.